Hi folks, today we're looking at more challenging implicit differentiation questions. The big thing to remember from the last lesson is that when you differentiate something that involves y, you need to tack on a y prime. Okay? And that really comes from the chain rule, though maybe it doesn't really look that way to you. X's behave nicely, y's tack on the y prime. So here's a weird little relation. We've got x squared plus sine y equals 3x. Let's take a look on Desmos. Weird, huh? But we can still differentiate. X squared becomes 2x. 3x just becomes 3. And the sine y is where we have to be careful. So this is chain rule at work. Sine y is going to turn into cos y. Well, we differentiated something that involved y, so we have to tack on a y prime. Because that would really be the derivative of the inner. The y turns into a y prime. Now, I want to rewrite it so that I'm clear what's going on with this y prime. It's not in with the angle here. We're not taking its cosine. It's y prime times the cos of y equals 3. After that, getting y prime on its own shouldn't be too big a deal. We've got y prime cos y equals 3 minus 2x, and then we can just divide by cos of y. And there we go. There's our derivative. Here's another challenging one. We've got y equals x plus 2 over y minus 1. You could take this as a quotient rule, and it will work out fine. And I've done it that way in the work solutions as one approach you could take. But a couple of other strange things happen here. Number one, you could look at this graph on Desmos. You'll find out that it's a parabola on its side with a hole in it, which is super weird. You might say that it's already in explicit form, so it's easy to differentiate. But notice there are y's here and y's here. So you're going to have a bit of a mess over here with your quotient, and then you'll have another y prime over here. You'll have to collect your y prime terms. So my suggestion is, if you have a quotient that involves x's and y's, then I would try and get rid of that quotient. And this isn't the first time in math that we've tried to get rid of fractions in an equation. It makes our lives a little bit easier. So let's see what happens. I'd get y times y is y squared minus y. On this side, these would all be gone. None of this is calculus. So I haven't done any calculus yet. Now what I'm going to do is differentiate. Now, differentiate. If you don't see any y primes in the step, then we haven't differentiated yet. So y squared is going to turn into 2y times y prime. This y is going to turn into a y prime. Its derivative would be 1, and then tack on the y prime. This x turns into a 1, and this 2 turns into a 0. At that point, we've got multiple y prime terms. Let's factor out that y prime, just like we did in the last video. And we get a really elegant expression for the derivative. If you do it with quotient rule, you're going to get a slightly uglier expression for the derivative, but it will still be correct, and either one's a correct answer. And again, you can check that out in the PDF that's linked just down below. In this last example, we're going to put all this stuff together of finding slope and finding the equation of a tangent in the context of an implicit differentiation question. So this one has a lot happening in it. Let's try and parse it a little bit. We've got x minus y all squared. We could FOIL that out if we wanted to. I'm going to try and take it just as its own little glob and use the chain rule on it. But it's up to you. We've got plus y squared, and then we've got an xy here. So that's going to be a product rule, and we have a plus 4 on the end. So let me set up that product rule while I'm at it. I'm going to have my u is x, my u prime is 1, my v is y, and my v prime is the derivative of y, which is y prime. So now we're ready to differentiate. Here's how I'm going to deal with this squared bit. I'm going to have the power come down, and the power goes down to a power of 1. I don't necessarily want to write that power of 1 because it looks kind of like a prime. So let me get rid of that. Then it would be times the derivative of the inside. So x minus y would have a derivative of 1 minus derivative of y would be y prime. Next piece, y squared turns into 2y times y prime. Next piece, u prime v, so 1y plus uv prime, so x, y prime, and then the plus 4 just turns into a 0. So maybe I'll write that there so that everything is accounted for. So again, chain rule here. Power came down front, power went down by 1 times the derivative of the inner. So this was outer prime, and this was inner prime. This one was pretty straightforward, 2y times y prime, and here was our product rule. I am going to have to FOIL all this stuff out in order to try and get my y primes all on one side. So let's see what happens next. I'll have 2 by x times 1 is just x minus x y prime minus y plus y prime, good grief, plus 2y prime equals y plus x y prime. Okay, let's deal with this 2 next. Maybe some of you did that all in one step. I'm a little nervous that I'm going to make a goof. And there should be a plus here. Okay, from that, plus another 2y prime equals y plus xy prime. Okay, maybe there are some like terms that I can collect. I don't know, let's see. 2x minus 2xy prime minus 2y. Oh, these are the same. So 4y y prime equals y plus xy prime. I got a lot of stuff happening here. I want to put my y primes on one side. I think I want to put them on my left-hand side because I have more y prime terms there. So let's see, this 4y prime, that's going to stay. This is going to stay as well, and I'm going to move this one over. So I'll have negative 2xy prime minus another xy prime. Okay, I've dealt with those ones. I'm going to put a little check on them. I'm going to leave this y over here. And I'm going to move some of my other stuff over. So I'm going to add this 2y on. And I need to subtract 2x. Okay. So let's see what we've got. We've got 4y, y prime, minus 3x, y prime equals 3y minus 2x. I'm going to factor out this y prime. It'll give me 4y minus 3x all over 3y minus 2x. Or lastly, this expression. As long as I haven't made any goofs. Now at this point, I've run out of board space. I'm going to use this result because I actually want the equation of the tangent. And to find the equation of the line that's tangent to this relation, I'm going to need to know a point. Yay, I know it. And a slope. I'll use this to find my slope. So I'm going to need to erase some of this. You can pause it here if you want to go through the steps. there's that derivative that we painstakingly found. Remember that it means the slope anywhere on the relation. So if we want the slope at 2, 3, we're just going to sub in those x and y values. Okay, let's see what that will look like. So y prime equals, let's be clear here, this is the x, this is the y. So 3 times 3 minus 2 times the x value, which is 2, all over 4 times the y value, which is 3, minus 3 times the x value, which is 2. Okay, clean it up a little bit. That's 9 minus 4, so that's 5. We've got 12 minus 6, so that's 6. This is the slope of the tangent at the point 2, 3. Are we done? Let's see. Find the equation of the tangent. Oh my. So we've actually got to find now the equation of this line. So y minus, there's our y1, y minus 3 equals slope, which we now know to be 5/6, x minus 2, and we can just rearrange. 5/6 x minus, let's see, this will be 10/6, or 5/3. And now I have to add 3 onto each side. 3 is the same as 9/3. So if I add 9/3 onto this, I'm going to have 4/3. Now here's the moment of truth. Let's head over to Desmos and see if it really does look like the tangent to this relation at this point. Fingers crossed. Yay! We got some graphical confirmation that what we did was correct. So at this point you should be okay to go with the rest of the implicit differentiation practice. Let me know if you have questions. And again, the big idea here is that we're differentiating these relations where it's hard to get y on its own, or possibly impossible to get y on its own, and that whenever we differentiate something that involves a y, we get a y prime. On Friday, I'll send out that recap video and also the formative quiz. Good luck!